Today we're going to solve absolute value inequalities. Your learning target is I can solve an absolute value inequality. So now we're going to be putting together two things we've learned about, absolute value expressions and inequalities. So for this first example, solve the absolute value of x is less than 3. Remember that absolute value is the distance from 0. So this is saying that the distance x is from 0, the distance is less than 3 away. Well, I'm not quite sure if it's 3 away in this direction, or it could be 3 away in this direction. So I know I'm somewhere, not including 3, because it's just less than, so I'd be somewhere in here. All of these values would be a distance of less than 3 away from 0. Now, looking back at what we did on compound inequalities, does this look like the graph of an and or an or? Well, hopefully you said and. So I can change this statement to x is less than 3, because we can see x is less than 3, and x is greater than negative 3. Let's take a look at this one. Solve x, the absolute value of x is greater than 3. So now the distance, some number is from 0, is more than 3 away. So again, I don't know the direction. It could be 3 or greater. That would be a distance of more than 3 away from 0. But I also could go in the negative direction, and I could be 3 or more away from 0 in this direction. So both of these would satisfy this inequality. Does that look like an and or an or? Well, hopefully you thought or. So I could change this statement to x is greater than 3 or x is less than negative 3. Now, when we do these problems, we actually are going to break it into two cases, just like we did when we solved absolute value equations. Notice on the second case, it's going to change to the opposite, just like we had with absolute value equations. But in addition to that, on the second case, the inequality symbol flips. And you can think of it as because we're multiplying by a negative 1. And when you multiply by a negative, you flip the inequality. So let's try another problem. The absolute value of 4k minus 8 is less than 20. Now you might want to look back at what we just did to determine if it's an and or an or. Notice that the less than problem was an and the greater than problem was an or. And you can use that to help you decide what to do here. So since it's a less than problem, the less than problem was an and. So we're going to have an and connecting these two statements. So I'm going to do my two cases. The first case, you're just going to drop the absolute value. There's the first case. And the second case, we'll have 4k minus 8 is greater than negative 20. Flip the inequality because we're multiplying by a negative when we go the other direction. From there, it's real simple. We're just going to add 8 to both sides. We get 4k is less than 28. Divide by 4. And we get k is less than 7. And here we'll add 8 to each side. So we have 4k greater than negative 12. Divide each side by 4. We get k greater than negative 3. This is an and. Now you can combine it into one statement, but I would recommend you look at a number line first. It will probably be easier for you to combine it into one statement. Negative numbers on the left, positive on the right. It's in between. So if you were to write this, you could say that my number k is in between negative 3 and 7. And you could write it like that. interval notation would look like this. Again, remember, you know it's not an ordered pair because we're talking about inequalities. All right, here's another example. Now, just like with absolute value equations, you have to isolate the absolute value portion first before you can break it into the cases. So we are going to start by subtracting 3 from both sides. I still have absolute value greater than 9. Now I can do the two cases. So I have 2x plus 1 is greater than 9. Oh, I need to decide first if this is an and or an or. Greater than, again, you can look back, hopefully in your notes, or rewind on the video. Greater than is going to be an or. So we're going to have or 2x plus 1 is less than negative 9 for the second case. Flip the inequality, change the sign of the number. So we have subtracting 1 from both sides gives me 2x is greater than 8. Dividing both sides by 2 gives me x is greater than 4. Subtracting 1 on both sides gives me 2x is less than negative 10. Dividing by 2 gives me x is less than negative 5. Don't forget the or. So now when I put this on a number line, negative 5, negative numbers on the left, positive on the right, I have less than negative 5 or greater than 4. Okay? Why don't you go ahead and pause this, practice these two problems, and when you have an answer, come back to this or hit play. All right, on the first problem, you want to identify this as an or. So we have b minus 4 is greater than 6, or b minus 4 is less than negative 6. Here we have b is greater than 10, or b is less than negative 2 when you add 4 to each side. So on our number line, by the way, this is our solution, but on our number line, when we graph it, we have less than negative 2 or greater than 10. So there's our solution on a graph. On the next problem, remember you have to isolate the absolute value first. So we have the absolute value of 7x is less than negative 4. Now, keep in mind that this would be an and, all right? So now let's think about this. A distance, remember, think of absolute value as a distance. So it's a distance is less than negative 4. Well, that should kind of send up a red flag because you can't have a negative distance. And this answer is actually no solution. So you have to watch out for problems like that. Now, suppose you didn't notice that and you just kind of plowed right through this problem and said 7x is less than negative 4 and 7x is greater than 4. And you divided by 7, so you got x is less than negative 4/7 and x is greater than 4/7. Well, think about it. How can you have a number that's less than negative 4/7 and at the same time is greater than a positive 4/7? Not possible. So, again, that's a reason why it's no solution. However, if you think about it up here, you can save yourself some work. And on this last one, we're going to write an absolute value inequality to represent this statement, all numbers less than 7 and greater than negative 7. Now the and is our hint because we know that tells us we're going to involve less than. So I can actually take a look at what this would look like. If we have negative 7 here, positive 7 here, by the way, 0 would be right in the middle, and is going to be in between. So this is just like saying the distance between a number and is less than 7. So we have some number, I'll call x. The absolute value is less than 7. This would be an absolute value inequality to represent that. So use this word. If it was an or, I would have had greater than instead.